Bruton Agammaglobulinemia is an X-linked recessive immunodeficiency syndrome that results from a defect in the BTK gene located on the X chromosome. It is caused by a defect in B cell production, which predisposes the patient to recurrent infections by encapsulated bacteria. In this video, I'll give you my visual mnemonic to help you remember the cause and symptoms for Bruton Agammaglobulinemia. Let's get started. First, take a look at the brooms here. The word broom should help anchor you to the scene to Bruton Agammaglobulinemia, because broom sounds a lot like Bruton, right? So why do we have all these brooms anyways? Well, it turns out that I'm covering this live TV story of the aftermath of a goblin attack. Everyone's got their brooms out to clean up the mess left by the battle. Just peg this broom to remember this scene on Bruton Agammaglobulinemia. Next, let's talk about how these goblins got into the building in the first place. Yeah, this is a pretty tall building, but it appears that the goblins climbed some beanstalks to break in. This feels like a plot to some fantasy movie. Anyway, take a look at the giant beanstalk outside. This beanstalk also reminds me of the BTK gene. Get it? Beanstalk for BTK? Bruton Agammaglobulinemia is caused by a defect in the BTK gene, which makes sense since BTK literally stands for Bruton tyrosine kinase gene. This gene essentially encodes a tyrosine kinase receptor needed for B cell development. And without this receptor, we have a lot of problems with B cells. More on this later. But for now, just remember this beanstalk to peg the BTK gene. Now that we've discussed the genetic cause for Bruton Agammaglobulinemia, let's shift our attention to the immune cells affected by this condition. Take a look at this bow here, which was our goblin's weapon. This bow helps me remember B cells, since bow is our recurring symbol for B cells. You see, B cells typically produce antibodies, which go on to fight infection elsewhere, kind of like shooting arrows from a bow. That's right, it's the B cell bow. But instead of arrows, we're shooting immunoglobulins. Anyway, in Bruton Agammaglobulinemia, a mutation in the BTK gene causes pre-B cells to fail to develop into mature B cells. Just remember that in Bruton Agammaglobulinemia, B cells don't develop properly. Now shift your attention to the dead goblin on the floor, who was defeated by the humans in this recent fight. You know how humans always win in these fights? This goblin is here to peg the term immunoglobulin. Get it? It's the immunoglobulin goblin. This dead goblin helps us remember decreased immunoglobulin levels. As we discussed earlier, Bruton Agammaglobulinemia results in impaired B cell development. And you already know that B cells produce antibodies, which are also called immunoglobulins. So if there are no B cells, there are no immunoglobulins. Should make sense. So what does this actually look like in a patient? You'll likely see very low or absent numbers of B cells, but the T cell numbers will be normal. This is because T cells are not the cells primarily affected by this disease. Moreover, you'll also see reduced immunoglobulins of all classes: IgM, IgG, and IgE. Note the name of the disease, Agammaglobulinemia, which refers to a lack of gamma globulins. Gamma globulins basically refer to immunoglobulins, so the name of the disease is basically another way of saying no immunoglobulins, aka no antibodies. This is super testable material, so watch out for it on test day. Next, notice our priest here holding his cane. Yeah, even goblins get last rites, right? Anyways, this cane is here as our recurring symbol for immunodeficiency. You know, the immunodeficiency cane. This should make sense, since the B cells and immunoglobulins form part of the adaptive immune response. No B cells and no antibodies leaves your body susceptible to infections. One thing to remember is the type of infections patients get. Bruton's Agammaglobulinemia causes recurrent bacterial infections from encapsulated bacteria, like Haemophilus influenzae type B and Streptococcus pneumoniae. Remember, these bacteria have polysaccharide capsules which are highly antigenic. In other words, B cells are normally very good at recognizing capsule antigens, and they produce antibodies which go on to attack the bacteria with these capsules. In other words, B cells are the major line of defense against encapsulated bacteria. However, because of the lack of B cells and antibodies present in this disorder, these foreign antigens don't provoke an immune response from the host. And boom, recurrent infections, immunodeficiency. Take your pick. Now, let's return to our priest. As he conducts the goblin's rites, notice the priest's cross. This small cross is our recurring symbol for X-linked recessive inheritance. Get it? A small cross for X-linked recessive inheritance? I mean, Bruton Agammaglobulinemia has another name, X-linked Agammaglobulinemia, for a reason. What this means in context is that Bruton's or X-linked Agammaglobulinemia is primarily seen in males. So in clinical vignettes, look for an affected boy with a family history of affected uncles and grandfathers. Afterwards, take a look at the smashed lymph-like plant here. The smashed lymph plant helps me remember the absent or underdeveloped lymph nodes and tonsils seen in patients with Bruton Agammaglobulinemia. Recall from your immunology class that after B cells mature in the bone marrow, they migrate out to camp inside secondary lymphoid organs like the tonsils and lymph nodes. So if there is a deficiency of B cells, the tonsils and lymph nodes will be much smaller, almost to the point of being unnoticeable. In other words, this is just another clinical manifestation of having no mature B cells. Finally, take a look at our live icon here in the corner of our scene. Yeah, I'm a reporter sent to cover the aftermath of this goblin attack on live TV. Not only is this live text here to show that this chaotic scene is being broadcast on live TV, but it's also here to help you remember that certain live vaccines are contraindicated in the treatment of Bruton Agammaglobulinemia. Why is that, you might ask? Well, remember that we're talking about immunocompromised patients here with no mature B cells and no antibodies. Live vaccines contain attenuated or less infectious strains of bugs, but they are still alive in the end, hence the term live. In an immunocompromised patient, administering live vaccines may cause severe infections. Yeah, no MMR for you. Boy, that was a lot of material to cover. Let's do a quick review. Bruton Agammaglobulinemia, also called X-linked Agammaglobulinemia, is an X-linked recessive disorder that results in decreased B cells and immunoglobulin levels. The causative mutation is on the BTK gene, a receptor tyrosine kinase needed for B cell maturation. Clinical findings include absent tonsils or lymph nodes. Patients are therefore immunocompromised, which leads to increased susceptibility to infections by encapsulated bacteria. Finally, certain live vaccines like the MMR vaccine are contraindicated in these immunocompromised patients because they could potentially lead to vaccine-related infections. Well, that wraps up this video on Bruton Agammaglobulinemia. I should pay more attention to the local news more often. Until next time.